Hello, I'm Supreetha. Welcome to my math class. So, in the previous class on hypergeometric series, we studied something about the Pochammer symbol. Yes, we defined hypergeometric series and then we saw the convergence on hypergeometric series using the D'Alembert's ratio test. Yes, now, did you know Sir Srinivasa Ramanujan played a very key role in the discovery of new theorems in hypergeometric series? And today we are studying those theorems in hypergeometric series. Okay, hypergeometric function shows up as solutions of many important ordinary differential equations. So, in your masters, you should have studied in the ordinary differential equation chapter, you should have studied something about hypergeometric function. Can you recall that? So, the hypergeometric function was z into 1 minus z, right? Into dy by dz, d square y by dz plus c minus a plus b plus 1 into z, the whole thing into dy by dz, right? Minus a b y is equal to 0. Yes, so this is called as the hypergeometric equation. So the hypergeometric function, that is y, is equal to 2f1 of a b c z. Yeah, this satisfies the Gauss equation in the region mod z less than 1. Okay, now to start with, consider the hypergeometric equation, that was z into 1 minus z d square y by dz square plus c minus a plus b plus 1 into z whole thing into dy by dz minus ab into y is equal to 0. Now let me keep the positive terms. Okay, first let me split it. Okay, z minus or z into d square y by dz square minus z square d square y by dz square, yes, plus c into dy by dz. Let me keep this as it is, a plus b plus 1 into z dy by dz minus aby is equal to 0. Now let me keep all the positive terms in the LHS and send all the negative terms to the RHS. That is z d square y by dz square plus c into dy by dz. Yes, this is equal to z square d square y by dz square plus a plus b plus 1 into z dy by dz plus a b y. Now on the LHS you add and subtract dy by dz. Okay, so z d square y by dz square, add dy by dz plus c dy by dz minus dy by dz. Okay, so in the RHS you can take z common over here, right? Take that out. Z, okay, z d square y by dz square. I'm taking 1z common. Okay, so here you have 1z, and you see I'm taking only this term. I'm multiplying z to 1, and I'm taking only that. From that I'm taking z common, so what would be remaining? Dy by dz, right? So what are the remaining terms? Let me write a dy by dz, right? There is a z here, let me write that as it is. Z into b dy by dz plus a b into y. Yes. Now from here, can I write it as dy by dz or dy dz of z dy by dz? Yes. First time when you differentiate, you would get dy by dz. Yes. You keep dy by dz as it is, and if you differentiate z, you would get dy by dz. You keep z as it is and you differentiate dy by dz, you would get d square y by dz square. Okay, so from here you see, if I take d by dz common, what would I get? Dy by dz. If I take it out, I would get c minus 1. Yes, this is equal to, so can you see that this and this are same? So let me write the same thing over here. Dy dz of z dy by dz. Okay, so now let me add one more step over here. That would be, so here let me write, what if I take z common? I would get plus a dy by dz. Yes, let me write the other terms as it is. Now let me take out d by dz common over here. Yes, I can write this as, I can take this a inside because it is a constant, right? I can write it over here. Yes, y into a. Now let me take out d by dz as constant. So I would get d by dz into z dy by dz plus a into y, right? Now here I can take out b common. Yes, so I would get z dy by dz plus a into y. So now as you can observe, these two terms are same, right? See, this and this are same. Yes, now I can write this as, so finally let me write d by dz of z dy by dz plus dy by dz into c minus 1 is equal to z d by dz plus b into z dy by dz plus a into y. Yes, now we should prove that LHS is equal to RHS. So I told you that y satisfies the Gauss equation, right? So now let me take y is equal to summation a at n, b at n divided by, what was this? Isn't this the definition of hypergeometric series? Yes. So now I've taken y as this one. So what would y dash? That is dy by dz, right? So that would be summation n is equal to 1 to infinity. Yes, an, bn. It's because you're differentiating, it becomes 1. Okay, n factorial. Now differentiating with respect to z, so you would get n into z to the power n minus 1. Okay, what is z into dy by dz? So you're multiplying z over here. So you would get z power minus 1 into z. What would that be? So z cancels out. So z power minus 1 is nothing but what? 1 divided by z. Is it not? So z, what is z divided by z? That would be 1. So you would get an, bn, cn divided by cn into n factorial into n z to the power n. Now let me take the RHS part, that is z dy by dz plus ay. Okay. What was it? Z dy by dz plus ay. I hope I'm right. Yes. Now, what is z dy by dz? It is summation n is equal to 1 to infinity an, yes, bn divided by cn n factorial n into z power n, right? What is a? What is y? N is equal to 0 to infinity, yes, an, bn divided by cn into n factorial z power n. Now let me take one term out of this. Yes, because I want n is equal to 1 so that I can take common from both the terms. So what is a at 0? It is 1. What is b at 0? It is 1. Right. What is c at 0? That is also 1. What is 0 factorial? It is 1. What is z power 0? That is also 1. So this whole term becomes 1 when n is equal to 1. So we would get only this term a. Yes. So I would get a plus summation n is equal to 1 to infinity a at n, b at n divided by c at n divided by, yes, plus a summation n is equal to 1 to infinity n bn cn n factorial into z power n. Okay, now let us take common. A plus, what would you get if you take summation? It is all the same. So in this term you have n and in this term you have a, right? So what would you get? N is equal to 1 to infinity a n b at n divided by c n n factorial. So you would get a plus n into z to the power n. Okay, now what is a n into a plus n? So now a n is a plus 1, so on up to a plus n minus 1. Agree? What is a n plus 1? That is a plus 1, so on up to a plus n minus 1 into a plus 1, because it is a n plus 1, right? So what is now I want what is an into a plus n, right? So here you see, can I replace this whole part, this part, with an? Yes. So what would an plus 1 be now? It would be a at n into a plus 1. That is what we needed, right? We have in this equation an into a plus n. So let me replace that. So yes, for now let me okay, so let y1 is equal to this, okay, z into dy by dz plus ay, okay. Now I can write y1 is equal to, I'm just giving a term, okay, we can take, right, x is equal to a, we can just take that as something. A plus summation n is equal to 1 to infinity. Yes, what is a n into a plus 1? I can write it as a at n plus 1, right? So this is bn divided by cn n factorial into z power n. Okay, so from this equation we have solved for this part. Yes, for our convenience we've denoted this by y1. Now let me take this equation. Yes, so what would you get? What happens over here? If this is y1, we would get, now multiply this y1 inside this equation, okay, so we would get z dy dz y1 plus by1, right? So now let me find, we have y1, let me find dy1 by dz into z, okay. So what was that equation? Okay, let me write down this equation in the next page. Yes, so y1 is equal to so you see you have a over here, right? I can take this a inside this sequence. Let me write that. So this becomes n is equal to 0, right? When you had n is equal to 0, you got a. So now I'm taking this a inside the series again now. It would be n is equal to 0. Okay. Now, if you want, you can cross check. You give n is equal to 0 and check if you get back a. Okay. So now what is y1? y1 is n is equal to 0 to infinity a n plus 1 bn divided by cn n factorial into z power n. So what all do we need? We need dy1 by dz. Yes, that would be n is equal to 1 to infinity a n plus 1 bn divided by cn n factorial into n into z power n minus 1. So if I multiply z over here, what happens? This z goes away. That is z power minus 1, which is nothing but 1 divided by z. It cancels out. Now let me take this equation. What was it? Z dy1 by dz. Yes, z dy1 by dz plus by1, right? Yes, by1. What would that be? Summation n is equal to 1 to infinity a n plus 1 b n n divided by c n factorial n z power n plus b summation n is equal to 0 to infinity a n plus 1 b n divided by c n factorial into z power n. So the same thing happens over here. Take out one term out, you would get b. Yes, similarly as we did for a, and you would get bn into b plus n. So you would have to replace it with bn plus 1. So finally you would get n is equal to 0 to infinity a n plus 1 b n plus 1 divided by c n factorial into z power n. Okay, so this was RHS. Am I right? This was the RHS part of the equation. Now let us consider the LHS part. Okay, can I write this further as d by dz of z dy by dz plus y into c minus 1? Yes. Now let me replace y by, or let me consider the LHS part. What was the LHS part? First let me take this one, okay? dy by dz plus what was it? Y into c minus 1. So what was z into dy by dz? Go back. What was it? Yeah, an bn divided by cn. Yes, substitute the value. N is equal to 1 to infinity a n b at n divided by cn n factorial n into z power n. Yes, and then n is equal to 0 to infinity. What was y? Y was the definition of basic or the hypergeometric series. Yes, which is also called as the Gauss series, into c minus 1. You can either write c minus 1 over here, or you can take it out as common. So the same thing again. What happens if n is equal to 0? What happens if you substitute n is equal to 0 over here? You would get 1, right? So I'm taking one term out, that would be c minus 1 plus n is equal to 1 to infinity an bn divided by cn n factorial into n z power n plus c minus 1 summation n is equal to 1 to infinity an bn divided by cn n factorial into z power n. Okay, so yes, what happens after taking out the common terms? Hypergeometric series might feel lengthy, okay, but you see it is very easy. If you practice it more than 2 times, you would surely do it correctly in the examinations. Okay, you might feel like you know everything, but you can only check yourself when you sit down and try proving it. Okay, I would suggest you to prove it at least 2 to 3 times. Yes, so after taking it as common, I would get c plus n minus 1 into z power n. Okay, so in all the other terms we got a plus n, b plus n, right? Here we got bn. Okay, where is that? Yes, we got a plus n over here, right? Over there we got b plus n, but here we are getting c plus n minus 1. Okay, for this, for a change, let us take cn. Yes, what is cn? Pajama symbol again. C minus 1, so on up to c plus n minus 1. Right. What is c? N minus 1. So in this series, you just remove one term. Yeah. You would get c plus n minus 2. Right. So how can you combine these two? What if, okay. So you would have c2, c plus n minus 2 over here, right? Yes, so let me write cn as, what can I write cn as? Cn is equal to c n minus 1, c plus n minus 1. So what do we have in this equation? We have cn minus 1 divided by cn, right? So c n minus 1 divided by cn would be 1 divided by c plus n minus 1. Agree? So yes, after this, what can I write? Let me get back to that equation. Which one? This one. Yes, let me replace it. This is equal to c minus 1 plus summation n is equal to 1 to infinity an bn cn. Is it cn? No, I would have to replace it with what? C plus n minus 1. Is it? No. So yes. So what do I have over there? I have c plus n minus 1 divided by cn, right? So what would I get? Okay, so I would get 1 divided by c at n minus 1. So let me replace that over here. Okay. So here c n minus 1, and I would get n factorial, yes, and zn. Now this was z dy by dz plus y into c minus 1. Yes. So now we'd have to differentiate it again. Yes, that was the LHS. So when we differentiate, we'd have to get the RHS part. Right. Now let me differentiate this. For time being, let me just denote this as something like P, for example. What would dP by dz be? Okay, let me mention that over here too. We are just denoting this by P or LHS. Okay. Yes. So if I differentiate, this is a constant, it would be 0. So that would become n is equal to 1 to infinity an bn divided by c n minus 1 n factorial n into z power n minus 1. So now we have n divided by n factorial, right? Can I write n factorial as n into n minus 1 factorial? Yes, n and n gets cancelled. So let me replace it. N is equal to 1 to infinity an bn divided by c n minus 1 factorial z power n minus 1. Here let me replace n with n plus 1. Yes, what would happen if I replace n with n plus 1? This is the LHS part, right? So you see, you would get n is equal to 0 to infinity. Yes, if I replace n plus 1 and 1 gets cancelled. So I would get n is equal to 0. I'm replacing n with n plus 1. B n plus 1 divided by c. Yes, what happens? N plus 1 minus 1. Yes, n factorial z power n. Is this the RHS part? Can you compare it? Yes, n factorial z power n. So LHS is equal to the RHS. Yes. So yes, this was the solution of one of the important ordinary differential equation, that is the hypergeometric equation, right? So what did we do? We just wrote down the hypergeometric equation. Yes, we did some simplifications. We kept the positive on the LHS and all the negative terms we sent it to RHS, making it as positive. Yes, we added and subtracted dy by dz, and after some simplifications we ended up with a LHS and RHS, right? So the hypergeometric series, we took y is equal to summation a and b n divided by c n n factorial into z power n, right? We differentiated it, multiplied it with z, because that is how the equations are. We substituted back in the LHS and RHS, and we proved that it is the same using the hypergeometric series. Yes. So yes, that is it for this class. Thank you.